Welcome back. In this video, I'm doing the Leetcode question. For today, that's 650, 2 keys keyboard. It's a Leetcode medium. So, there is only one character A on the screen of a notepad. You can perform one of two operations on this notepad for each step. Copy all. You can copy all the characters present on the screen. A partial copy is not allowed, or you can paste the characters which are copied last time. Given an integer n, return the minimum number of operations to get the character A exactly n times on the screen. Okay, if input is 3, we need 3 operations. So we have one character A. We use copy all to copy it and paste. Okay, and if input is 1, then it's 0. We have constraints between n is between 1 and 1,000. Okay. So this is somewhat similar to what we had yesterday and a few days ago. So we are going to get n, and that's the minimum number of operations to get a character A exactly n times. So what do we know? So in one step, so with 0 step, we have already 1A. With 1 step, we can have A, and we can just copy. Okay. Yeah, we can just copy and we still got only A. If we have 2 operations, then we can copy and paste. So A. If we can, that's 2 operations. This. So this is 2. Three operations, it's A first, copy is second. Oh, sorry, we already have an A, so we copy and paste. So, and essentially, like, let's try 4 one more time. So 4 is 4. How you're counting number of A's here? Okay, but essentially, idea is this: like, what do we know? Let's get back to first what I'm trying to say. So each number, each positive integer is either 1, prime, or composite number. If it's 1, in this case, we just return 0 because we already have an A at the beginning. If it's prime number, we can get prime numbers only by adding it, copying A, so that one A, and then pasting all the time to get prime number. Because if we paste and get some other number, let's say 2, so we will never get like a prime number. If we have 3, because what are prime numbers? Prime numbers, only 2 is even prime number, and after 2 it's all the numbers that can only be divided by themselves in 1. So 3, 5, 7, 9, it's not, because it's divisible by 3, and so on. So essentially, we know for the prime number, how many steps do we need? Since we need to copy, that's 1 step, and we already have 1. we need one step for copy and one step for each A till we get the target number. But since we already got one A, that's exactly prime number steps, and we return prime number. So return prime number, and we know that for composite numbers, it's actually factorization of multiple prime numbers. And how do we factorize in this sense? So we know we'll have multiple, like when we factorize it, we'll have multiple prime numbers. What do we know? So for one prime number, let's say we have 14. So 14, that's 7 times 2. So these are two prime numbers that are. We know that we can build 7 with 7 steps. And how do we multiply 7 by 2 or by any prime number? We just need to copy it. We just need to paste it. So number of times minus 1 because we already have. And what do I mean? Like let's say we have 21. That's a very better example. So first we need 7 operations to get 7. And how are we going to get from 7 to 21? So this is to get 7 A's, we have 7 operations. And then we copy this 7 A's and C will be copy. And then we'll paste once to get 14 and once more to get 21. So, and let's say we have like, what is the, actually I'll write a new one, so this is 21. And let me write, let's say we have something similar, so 7 times 3 times 3. We again need to do 7 to get prime number 7. Then we need to copy it and paste it 2 times to get 7 times 3. So that will be 7, copy, paste, and we get 21. And then to get times 3 again, we just copy and paste. I think you get the idea. So essentially, what do we do all the time? We just sum the prime factors this number is made of. And that's actually it. So the result is, if it's number greater than 1, it's actually always factorization, sum of prime number factorization. So for the prime number factorization, we have only prime number times 1. So it will be just prime number. And for composite number, it will be factorization of multiple prime numbers. So it will be sum of prime numbers. Okay, let's try to write this. So we'll have result, and at the beginning it will be 0. And what do we do? So what happens? So okay, now I showed you how do we get any number, and we can see that it's sum of prime numbers. How will we know how many prime numbers there is, which are prime numbers. So like the same thing we did yesterday and a few days ago, we need to try each number between so between 2 and on, and see if the number we currently have can be divided by. So if n modulo that number is equal to 0, that means it's a prime number. How are we going to make it so it surely is prime number? We're going to make it in a way that if we encounter a situation that n modulo that, let's call it d, is equal to 0, we will divide it by d. And we will move from that d, we will increase d by 1 to find next prime number only when we can't divide n, only when we have n modulo d is not equal to 0. So let me write it out, it will make more sense. So what do we do? While, I'll just write it and then explain it. So while n is greater than 1, and while n modulo, let's say d, so d will be equal to, is equal to 0, we will add the result d. We will also decrease n divided by d, and we will increase d. Oh, I'm a bit tired, so I'm not sure what I'm writing at the moment. Okay, so we'll increase d, and in the end, we'll just return our results. So let me explain what's happening here. So first we initialize the result. If n is equal to 1, then we know we don't need to do any operation, we return result. And if it's greater than 1, then we need to try, then the number is either prime number or factorization of multiple prime numbers. So as we saw, for each prime number we need to sum it, and that's this part we are doing. So if it's sum, we can divide by d, that means that d is a prime number, because when we get 2, we will divide as much as possible, as much as the n modulo d is equal to 0. So after we finish with 2, we get to the next number. Since next number is always prime factorization of previous number or either prime number, that means that each number we already each d we encounter with this, and where this is true, that d will be a prime number. I hope it makes sense. I'm not sure if I'm like explaining it 100% correctly, but we'll pass through one example to check the code. So each time we can divide, let's say we have something like we had here like 21. So 21 is the input, 21 is n, 21 is greater than 1, that's okay. When we try to divide 21 by 2, it's 0, so we increase d. D is now 3. When we divide 21 by d, we get 0. So modulo d is equal to 0. We need to increase result by d because we need to build that prime number with with a's. That's the first step. Build the first prime factorization we found, but it doesn't matter. whatever prime factorization we need to build it first. So we need to add 3. So res is 3. And then we divide it, we get 7. So n is 7 at the moment. 4, that's composite number. 5, that's prime number, but it's not 0 modulo 7. So 7 modulo 5, it's not 0. 6 also no, and 7. When we get to 7, we'll also append it, increase result by 7 and divide n. And since n is now 1, this outer condition will be false and will just return the result. So that's why it's also 1 here, because when we divide by 1, when n is equal to 1, that means that we found the highest prime number, that that is factor in that factorization. And maybe if it makes like more sense, so we know that each composite number is, like I said, factorization of multiple prime numbers. And we know that one prime number is max, or each is the same. So to get, like, let's say 13 times 3, that's 39. So to get 39, we can either like build 3 A's, that's 3 steps, and then copy and paste it. So 12 more times. We have 3, and we need to copy the highest prime and minus 1. Also is the same for when we build it like first 13 A's, and then we need to copy it and paste it 2 times to get 39, because we have 13 and those two paste 13, that's 39. Okay, this was a lot of talking. Let me try to run it. Okay, not bad. What do you expect? To just do this. Okay, test cases correct. And it's also right here. So as we can see, it's pretty efficient. And now for the time and space complexity. So we actually know that, like in worst case, is it's either prime number or composite number or 1. So 1 is 1 step. For the prime number, we need to do prime number times. So we'll need to increase the prime number times to find that prime number. And if it's factorization of multiple prime numbers, then it takes, okay, if this repeats, but the higher is the highest factorization of prime numbers. So actually the worst case is, I think, for 997, if I'm correct. I think 997 is a prime number. Let me check it for a moment. And yeah, so 997 is the prime number, and that's the worst case. So this will be all of n in the worst case, and for the space it's all of 1. So let's try it. Pretty efficient. Let's see if we can check it. Yeah, all of n, and this should be all of 1. That's correct. I'll just write it down. So Okay, I hope this made sense. If you have any question, leave it in the comments. Thank you for following through this one, and see you in the next one.